Okay, so my first announcement is we finished up lesson 12 yesterday. I assigned the homework and it is due next week on Monday, okay? Other things that are important announcements. I will be sending out an email either today or tomorrow. My hope is that I'll be doing it later on this afternoon. Essentially, this week, I just want to talk briefly about this week and next week, and then I want to jump into the math. This week, we have class tomorrow, as usual. Thursday, we never have class. Friday, there is not going to be a Zoom or an in-person 10 o'clock class. What I'm going to be doing is making a video where I'm pretending that I'm teaching to people, but really I'm just talking to myself. And I'm going to be posting it on our box folder along with notes. And I have to go to Bozeman tomorrow afternoon. And I'm going to be in Bozeman Wednesday, Thursday, Friday. There's a really big meeting there and I'm presenting at the meeting. So anyway, instead of getting a sub for class or instead of me Zooming the class, what I'm doing is I'm making this video of me teaching material. And I'm going to send you all in an email a link specifically to that video and specifically to those notes. And then next week on Monday, I'll of course answer any questions and fill in anything that we need. Okay, are there any questions about that? So Friday, you're free at 10 o'clock unless you want to actually just be in the spirit of our Math 115 class and watch the video and do all of that at the same time. Are there any questions on that? Okay, well, cool. So be expecting an email. One of the things I'm doing this afternoon is I'm going to be making that video. Once I get through class today, I'll have a good idea as to what I can get through tomorrow and therefore what to make for the video on for Friday. Okay. The other thing in that email is I'm going to talk about the remaining in-class activities / worksheets. So we have done 6. There's a total of 10 for the semester, which means we have 4 more. But what I'm going to do is I'm going to double each of them up. So the next worksheet is going to be worksheet 7, 8. And then the final worksheet will be 9, 10. And I'll grade it. I won't, you know, this worksheet 7, 8, the first part will be the points for worksheet 7, the second part for worksheet 8. But I figure at this point in the semester, given what we have left, it's easier just to hand you 2 assignments that are a bit longer. Okay, so the activity over 7 and 8, worksheet 7, 8 is going to be on lesson 12 and lesson 13. And then the last one will be over the final lessons before we finish up the class. Okay, so that's the deal with this week. Next week, we have class as usual on Monday and Tuesday. But then you're off on Wednesday and Thursday and Friday for Thanksgiving. So we do have 2 days of classes next week. I realize that some people travel earlier in the week. And that's the beautiful thing about the Zoom option that you have. You could Zoom in from home. Or B, you can access the recordings when it's convenient for you. Okay. But I do want to say that we do have 2 days of classes next week. Then we're off for Thanksgiving. And then we have, I think, just like 2 or 3 more weeks after that. And then that's a wrap for the semester. So that's pretty cool. Any questions whatsoever? Okay. Well, then, what I would like to do, first off, I want to start lesson 13 today. I do, because we're not having class on Friday, and I'm making a recording that I'm just going to ask all of you to access. My suggestion would be, if you have not already started lesson 12 online homework, that you work through that, perhaps today, at least to a certain extent, and then bring questions for me in class tomorrow. Okay, I'm happy to go through that. That'll give you an opportunity to get your questions answered before the weekend, because my hope is that you'll have it finished up before next Monday when it's due, just because we're going to be needing those techniques. Cool. Any questions from anyone on Zoom? All right. So let's get moving here. So what we're going to be doing in this section in lesson 13 is essentially taking our linear equations and actually using them as a mathematical model, okay? We started doing some word problems yesterday just to get us primed and ready for this section. In this particular section, we're really only going to hone in on one type of word problem for the most part. And what we're going to be dealing with is cost, revenue, and profit. Okay. Again, I had mentioned that we're doing these sections as a service course for the business school. So those of you who are business majors, or at least thinking of going in that direction, this is going to help prepare you for your other classes in business. And those of you who are not at all business majors, I mean, we do live in a capitalist society, for better or for worse. I'm not making any comments on that. But what I am saying is these are realities. Okay, money exists. So I'm going to define each of these terms. We're going to go through these things one by one. For the sake of this class, we're going to assume all of these can be modeled using linear functions. Okay, there are a ton of other functions. That's just a huge study in math, is all sorts of different functions. And if you want to study functions deeper, I urge you to take like a college algebra class. That's when we get to study all different sorts of functions. And I teach that. So if anyone wants to take it in the spring, it should be nice to have you in there, because everybody wants to take another math course, right? Anyway, these can be modeled using quadratics and other sorts of functions. But for this particular course, we're just going to model everything using linear functions. In other words, y equals mx plus b. Okay, so I'm going to start by talking about costs. Okay, when we talk about costs, when we're dealing with linear functions, they come in two parts. Okay, and essentially those two parts are what we call our fixed costs, and the other part is what we call our variable costs. Okay, so our general cost function, instead of writing y equals mx plus b, we write c of x. Don't let this notation mess with you. It's actually much more convenient notation than just always having a y. This c stands for cost because we're just not very original in the math world. And we're saying that our cost is a function of X. So X is our unknown, our variable. And more often than not, in these situations, X is going to represent the number of items produced. Okay? So if I let X represent the number of items produced, let's think about what this M means and what this B means. And what I'll say is that C of X is the production cost and will be in dollars here, okay? So do you agree if I produce nothing? That means I'm letting X be equal to 0, right? If I say, well, I'm not going to produce absolutely anything, do you agree then I'm saying X is equal to 0 here? Well, in the context of a linear equation, what does it mean when X is equal to 0? Isn't that by definition our y-intercept or our value of B? Okay. Right? If I plug 0 in for X, whatever anything else is, I'm going to be left with B. That's our y-intercept. So essentially what the M and the B translate to here is saying that if I produce nothing, I still have costs. Those are called my fixed costs or my overhead. Okay. So X equals 0 is our y-intercept, and B represents our fixed costs. Okay, so what are fixed costs? Well, if you own your building that you have your company, you got to pay taxes, you got to pay electricity, you got to pay, hopefully, your employees' health insurance. You know, you have a lot of just basic costs that just exist for having this business, insurance, all of those things. Y'all with me on these overhead costs? If you don't own your building, you've got rent to pay. You know, again, we also have all of our utilities and that sort of thing. Y'all with me on these overhead costs? Okay. All right. So thus far, what we've established is if we have C of X equals MX plus B, our y-intercept in words represents our fixed costs. And X is the number of items produced. Okay? Do you see how that works out naturally, mathematically in this equation? All right, well, M is the other thing that's going to take on a particular meaning. We know that M is our slope. And we've talked about slope in terms of rise over run. In other words, the change in Y values over the change in X values. Okay, what you want to do when you're talking about these things is think about the units. Okay, if our slope is the change in Y values over the change in X values, or in this case, the change in cost, do you agree that the units we have for our cost function are dollars? And then, so we have dollars per. Well, what are the units for our X value? Isn't that items? Okay, remember how our computation of slope is it's a rate of change. And again, it's our Y values, or in this case, our cost function, and our units there are in dollars, and then over our X, change in X value, which is the number of items. In other words, what our slope gives us is the cost to produce each item. This has some technical names. It can be called your variable cost. Another term that's used very frequently, especially for anyone going into economics, is you talk a lot about marginal costs. Okay, so be prepared for any of these words to be used when we discuss our slope. Okay, so if there's any questions this far, please stop me and ask. All right, let's do this example. Suppose we have a donut shop. And suppose it has fixed costs of $600 per week. Whoa, that's pretty steep. And suppose each donut costs 5 cents to produce. Now, when we talk about the production costs, you know, we're talking about our supplies, whether it's packaging, whether for donuts, it's, you know, the flour, the sugar, and the butter, right? I'm not really sure what goes into donuts, but. Well, if you're given this sort of information, I claim we can write an equation for our cost function. Remember, we let X, in this case, we let that be the number of donuts we make. Okay? Can somebody tell me what is my slope here? Well, the slope is the cost to produce each donut. How much does it cost to produce each donut? 5 cents. Now, notice I'm keeping my cost in terms of dollars, so I would write that as 0.05x. And what are my fixed costs? $600. Okay, now, is it normally going to be given to us this directly? In our dreams, right? But it sure is nice to take it while we can. Okay, so do you agree, for example, if I make, say, 100 donuts, I can then figure out what the cost is for me, right? Because I would plug in X equals 100, and I would see that it would cost me a whopping $605. You all with me here? Yes. Okay. So we are going to be playing with these functions, but let's play with this function. So playing with this function, find the cost to produce 100 donuts. We're going to do 2 quick examples here. Okay. In this case, do you agree we want to find our cost? Okay, so our only unknowns are our C and our X. Okay, if I want to find C, I better be given X. And do you agree in this case I am given X? Okay, so we can say, well, we want to find the cost when X is equal to 100. So you would take 0.05 times 100 and then add on 600. On the other hand, I could say, find the number of donuts we can produce if we can have our costs total to, I don't know, $1,500. In this case, would you grant me I'm given my cost And what I want to do is find the number of donuts. Okay, so now we have this value. We have that is 1,500. And we want to find the value of X that gets us there. Does that make sense? Cool. So can I solve this for X? One hopes. What would be my first step to solve this for X? Subtract 600 from both sides. Do you agree we have 900 equals 0.05X? How do I get X alone? Well, I got to undo multiplication. How do you undo multiplication? Divide. So I divide both sides by 0.05. We can make a whopping 18,000 donuts. Questions? I don't even know the last time I ate a donut. Come to think of it. Yeah.
To the topic. So what, do you do anything with the 100 on the left side?
No.
Okay.
You could just essentially even rewrite it, the function like this, if it messes you up to put the variable in here.
Yeah.
And then just plug the 100 in for X.
Okay. All right.
No, that's a great question. I know this notation can be funky for people. The thing is in math, sometimes we have functions, not just of one variable, but we have functions of many variables. Don't worry, we don't go there here. And so whenever we talk about a function, we identify what the variable is. But if it messes with you, then don't write it. It's cool. All right. Everyone online okay right now? All right. Well, what if, okay, cool. Thank you for responding. I appreciate that. I just want to be sure you're all with me here. So what if now I want you to find the cost function for this scenario? Suppose I tell you that the fixed costs are $100 and 50 items cost $1,600 in total to produce. Now, as you might predict, I'm going to go through one of each type of thing pretty much that you're going to see, just to be sure that you have experience with all of these. So again, the first thing I see is I want to find my cost function. So the first thing I'm going to write out is my linear function. Now, the nicest situation is when we're actually given the value of M or the value of B. And in the previous one, we were given both, okay? I claim we're only given one of those values here. What are we given? We're given B. We're given our fixed costs are $100. Okay, so I've used this one piece of information. The other piece of information I'm given is that when X is equal to 50, my costs are 1,600. So now what I'm given is I have my y-intercept and I have a corresponding ordered pair. Now note the 1,600 includes our fixed costs, okay? So what I claim we can do is plug in these values for our C and our X to solve for M. I could say, well, our cost is $1,600 when X is equal to 50. All right, I want to find M. what would be my first step for solving for M? Subtract 100 from both sides. So I'll have 1,500, and I'm just going to write that as 50M. You can write M times 50. I'm just stuck in my ways. Okay. Now, how do I get my M all by its lonesome? Divide both sides by 50. So I'm going to get M to be equal to 30. So in this case, my cost function is 30x plus 100. In other words, our fixed costs are actually pretty low, aren't they? $100. Yeah, kind of like we're working out of our house, probably. But notice the cost to produce each item is non-trivial. It's $30 per item. You with me there? So hopefully you're all seeing why it's really important that you get lesson 12 done, because we're just playing with lines. We're just attaching words to it. Okay, another example where we want to find the cost function. Find the cost function if 50 items cost $4,300 to produce, and the marginal costs are $75. So I'm going to work through this example, and then I just saw a chat that I want to clarify. Okay. First thing, we want to find our cost function. That's mx plus b. We need to find m and we need to find b. What are we given directly in this particular example? We're given M. We're given that it costs $75 to produce each item. So already we can say it's 75x plus B. Now what we need to do is find B. Well, are we given any other information with which to do that? Totally. Aren't we given that when we produce 50 items, our total cost is $4,300? So now we can plug that in order to solve for B. Well, in this case, we have 4,300 on our left. You take 75 times 50, you're going to get 3,750. And how will I get B alone? Subtract 3,750 from both sides, and you're going to get 550 to be B. And this is our cost function. Now there's a question about the X, okay? If I have an equation of a line that looks like this, first off, I'm way too short to graph this line. I can't graph a y-intercept of 550 by any stretch of the imagination, okay? But if this was the equation of a line, okay, we have our slope and we have our y-intercept. There's infinitely many points that pass through this line, right? Whenever we have a line, there's infinitely many ordered pairs X and Y that live on that line, okay? So we always have these things, X and Y, or X and C of X, as our unknowns, okay? In this case, my output is just written as C of X instead of Y. If having the X here messes you up, then just write it as X comma C, okay? But you're always gonna have an X remaining in this equation because that's our unknown. And there's always infinitely many points that can fit in here, okay? So what I want to do is say, okay, let's take this guy. So I'll just write it like this. And suppose I ask you this question. I mean, if we find a silly equation, we might as well do something with it. What if I say the following? The total amount available for costs is $10,200. How many items can I produce if I want to spend all that money? All right, we have two unknowns. These are the number of items. This is the cost. What am I looking for? Not a rhetorical question.
Number of items.
Awesome, thank you. We're looking for the number of items. So we're looking for X, which means we better have been given C. And sure enough, we have. All right, I can solve this by first subtracting 550 from both sides. If I do that, I'm going to get 9,650 is equal to 75x. Now I'm doing this example intentionally, and you'll see why in just a moment. In order to solve for X, we would divide both sides by 75. If I do that, I'm going to get 128.66666 repeating. So the reason why I want to do this example is because we got this decimal here. So what is the answer? Okay. Is it 128 items? Is it 129 items? Right? We have our rules of rounding, right? Like if you want to round to the nearest whole number, typically you look one place over. If it's a 5 or larger, you increase that by 1. Remember that? And then if it's a 4 or smaller, you leave that the same. When you're doing word problems, you don't use the rules of rounding. You got to use just the logic of the actual particular situation we're looking at. I claim that we can only make 128 items. Okay. We can make technically 128 2/3 items. The thing is, we go in whole numbers here, no decimals or fractions, and we don't quite have enough money to get us to 129 items. Does that make sense to everybody? Are you thrilled? Okay, so that's our cost. Okay. More on the bright side of life, we can also talk about our revenue. The revenue is the amount of money we bring in. Okay. Now, I can tell you what the general equation for the revenue function looks like, but I also think that we could take a little bit of time and motivate it. Okay, so suppose I have a side gig. My side gig is I sell t-shirts for 20 bucks a piece. Okay, let's just talk about how much money I make. If I sell one shirt, how much money do I make? 20 bucks. If I sell two shirts, how much money do I make? I make $40, right? I sold two shirts that are $20 each. If I sell 5 shirts, how much money do I make? $100. Good. How'd you get that? Well, I'm selling 5 shirts. They're $20 each, and 5 times 20 gives me 100. Do you see a pattern between the number of shirts we sell and how much money we make? When we sold 1 shirt, we took the price that we charge times 1. When we sell 2 shirts, we take the price that we charge times 2. When we sell 5 shirts, we take the price that we sell each shirt times 5. What if I make X shirts and sell them? How much do I make then? Give me a guess. When I sold 2 shirts, I took 20 times 2. When I sold 5 shirts, I took 20 times 5. I'm going to take 20 times X. So if P stands for our selling price and X stands for the number of items sold, our revenue function, we generally write it as R of X. If you prefer just writing R, you can, is P times X. Again, the reason why we say R of X here is precisely because this is what's going to vary. The price that we sell them for is not going to change in the function. Y'all with me here? Okay. So this is something you need to know. So if I tell you that, I am going to instead, I don't know, I'm going to sell muffins for $5 a piece. Can I write a general equation for the revenue I'm going to bring in? Yeah. Aren't I going to make $5 per muffin times the number of muffins I sell? AKA 5X. And this is a really handy way of doing it, because then if I tell you I sold 100 muffins, that means I made 500 bucks. Y'all with me here? Awesome. Well, the thing is, we can't just look at our revenue. I mean, suppose we own a business, okay? The goal in this world here that we currently live in is to make a profit, right? We ultimately want to make money so that we can pay our bills, okay? So how do you determine whether or not you have a profit, and if so, what your profit is? Well, I claim what you do is you take all of the money you earn, subtract off all of your costs, and hope for a positive number. And again, we use P for profit, R for revenue, and C for costs. Okay, we don't just walk away with all of our revenue, because you know, making these muffins or donuts or t-shirts costs us money to make. Okay. If your profit is positive, if P is greater than 0, that means we make money. It means that our revenue was greater than our costs. That's the hope, right? You want to bring in more money than you spend. If P is negative, we lose money because that means that our revenue, in other words, the amount of money we brought in is less than our costs. This is how I feel in life when I look at like my bills and my paycheck, right? Darn it. And finally, we could have P equal to 0, but that means that our revenues are equal to our costs. When that happens, we call this our break-even point. Y'all with me this far? What do you think so far? Is this understandable-ish? Cool. So what I'm going to do is I am going to stop for the day right now. We're at a really good break point. I will see you in class tomorrow, and I will also then be making a video, et cetera, to replace our Friday class. Okay? Have a great day, everyone.